Hi folks, so this is question 6. So first question asks us to say if this statement is true or not. So vertically opposite angles are vertically opposite if and only if they're equal in size. So we'll give an example here. Right, so that's 120, and then we need 240 then for the rest of it. So just say that's 240. Okay, so there you have two angles that are equal. You've got two 50s in it, but they're not actually opposite to each other. They're not vertically opposite. So the other, if the one opposite to this angle would have to be over here. So it will be over here. So they're not opposite to each other. So therefore they don't have to be opposite to be equal. So that's basically the justification. So something like that is what you have to say. So it's false, the statement. Right, so part B then. So it asks us, we have to prove that EF is equal to EH. So EF is here, and then EH is here. So all we're going to do is we're just going to prove that this triangle and well, this triangle, you can see where I'm pointing to anyway, are congruent to each other. So if they're congruent to each other, well then that statement has to be true. The EF has to be equal to EH. So first of all, anyway, I know that there's two right angles there. Okay, so FED. So I'll just wherever I have space. Yeah, so FED is equal to HED. So both 90 degrees. Or right angles. I should have said right angles. So we know one of the angles are in both are equal anyway. If you look over the left hand picture, so we can see that that theta is down there, so theta has to be here as well. And this line at the bottom and this line at the top, they're parallel to each other because they're both rectangles. So therefore we can use the rules of parallel lines. So we know that this angle here, EHD, has to be theta as well. Okay, so EHD then has to be equal to DFE. So DFE we know is theta anyway, because over in the other diagram it says it's theta. So this one here has to be theta as well because it's the same thing. So we know that they're both equal, and it's because of alternate angles, really. So it's because CBD and EHD are alternate angles to each other. Okay, so because of that, we know that EHD has to be theta, and we're already given that the FE is theta. So therefore we know that that's equal. And then because we know two of the angles in the triangle are equal to each other, we know that the other ones have to be equal as well, because the angles have to add up to 360. So FDE has to be equal to EDH. So because they're the other angles in the triangle. And must add up to 180. Yeah, so I could have probably laid it out a little bit more clearer, but that's the generally what we're saying anyway. So there, that's proves that all angles in it are equal. And then we need to use one of the ASA, SAS, SSS kind of things to prove that the triangles are congruent. So we're nearly there. We can say that ED is the same as ED because that's in both triangles. So obviously it's going to be the same. So because it's in both triangles, it's the same side in both. It's the same length in both triangles. So ED is equal to ED. Because it's the same side in both triangles. So something like that. And then we can say that both triangles, so FED and EDH, are congruent to each other. So we know that they're congruent to each other now, therefore what we have is true. So FE is equal to EH. And that's all we need then. So that proves that's true. So we've proved that the triangles are, oh yeah, we should have said that triangles are congruent because of angle, side angle. Okay. So the right angle and then the ED and then the FDE EDH angles are equal. So by angle, side angle, or the side is in between them, it shows that that they're equal. Okay, last part. So hence or otherwise find the size of angle theta. So we're going to be using trigonometry here anyway. So get rid of some of this. Right, well we know anyway that down here from A to B is 20, therefore up here has to be 20 as well. So the full length from there to there pretty much is 20. Therefore this has to be 10 in here and this has to be 10 in here. I can just jump over to the other diagram on the left hand side then and I can put in that that's 10 there as well. So if that's 10, we know that the whole length of the bottom there, 20 and 30, has to be 50 altogether. So therefore the whole length of the top has to be 50. So that means that this part here from G to F has to be 40. And that, yeah, that's pretty much all we kind of need then. Now we're in a position, that's a right angle triangle there, and we're looking for theta. So it's 90 is the opposite from theta, 40 is the adjacent. So we can use trigonometry then. So tan theta is 90 over 40. Just double check that. Yeah, 90 centimeters over 40 centimeters. And then we just need to bring over the tan. So theta equals tan inverse 90 over 40. And that's going to be 66 degrees, so to the nearest degree when you round it off. So that's it, that's all you have to do then for that question. It's not too bad. It looks a little bit more awkward than it actually was, but that's it for question 6.